You know, for pretty much all of human history, we've only ever studied the universe with our eyes. Through bigger and better telescopes, sure, but we've always been watching. But what if we could listen to it? Today, we're going to dive into how scientists heard a faint, ancient echo from one of the most violent events imaginable, literally, a sound from the void. In this whole incredible story, it doesn't start with a bang. It starts with a chirp. So what you're looking at here, this isn't just some random squiggle on a screen. No, this is the actual fingerprint of a cosmic cataclysm. This tiny little chirp is a signal that traveled across the universe for more than 1 billion years, and it's telling us the story of two black holes smashing into each other.
And we know the exact moment it finally got here. On September 14, 2015, at precisely 9:50 and 45 seconds Universal Time, two different detectors, thousands of kilometers apart from each other, both caught this same exact whisper from deep space at the exact same time.
Okay, so that brings us to the big central mystery here, right? How in the world do you hear something that makes no actual sound? I mean, sound needs air or something to travel through, and space is a vacuum. So what was it that they actually detected?
Well, the answer lies in an event on a scale that is, well, it's just almost impossible to wrap your head around. A truly cosmic collision.
It all kicked off with a pair of massive black holes, trapped in each other's incredible gravitational pull. They were locked in what you could only call a death spiral, circling closer and closer, faster and faster. And as they got closer, whipping around at nearly the speed of light, they weren't just moving through space anymore. Oh no, they were violently churning the very fabric of space-time itself, sending out these powerful ripples, kind of like a speedboat tearing across a cosmic pond. And then the grand finale. In the last tiny fraction of a second, they collide and merge into one single, even bigger black hole, an event of just unimaginable violence. Now, to really get the scale of this, let's just look at the numbers for a second. The first black hole, it had a mass about 36 times bigger than our own sun.
Its partner was a little smaller, but still a monster, coming in at 29 times the mass of our sun.
So you do the math, right? 36 plus 29 equals 65. You'd expect the new black hole to be 65 solar masses. But it wasn't. The final merged black hole only weighed in at 62 solar masses.
So where did the missing 3 solar masses go? That's the mass of 3 of our suns. It's like they just vanished into thin air.
Well, they didn't vanish. That mass was converted into pure energy. And this is just a brilliant real-world example of Einstein's most famous equation, E equals mc squared. That missing mass became the raw energy that created those gravitational waves we detected.
And the amount of energy we're talking about here is just staggering. For a fraction of a second, the power output of this merger was so huge, it briefly outshone all of the stars in the entire observable universe combined. Just think about that for a second.
Now, as wild as this discovery was, it wasn't a total surprise. It was actually the amazing conclusion to a scientific quest that had been going on for a full century.
It all started way back in 1916. Albert Einstein, with his theory of general relativity, basically predicted that these ripples in space-time, gravitational waves, had to exist. For decades, it was just a theory. Then, in 1974, scientists Hulse and Taylor found the first indirect proof. And finally, after years and years of searching, in 2015, the advanced LIGO project made the first direct detection. They proved Einstein was right, almost exactly 100 years later.
So how did they do it? I mean, how do you even begin to build a machine that's sensitive enough to pick up on these incredibly tiny ripples? Well, you build the ultimate measuring device.
This is LIGO. It stands for the Laser Interferometer Gravitational Wave Observatory. There are 2 of them in the US, one in Washington State and the other way down in Louisiana. And having 2 is absolutely critical. If a weird signal pops up at both detectors, but not on any local earthquake sensors, you can be pretty sure it came from space, and not just, a passing truck.
Okay, so think of this thing like a giant cosmic ear. Here's how it works. A powerful laser beam is split in 2, and each half is sent down a 4-kilometer-long arm. At the end, super precise mirrors bounce the light all the way back. Now, if everything is perfectly still, the 2 returning light waves cancel each other out. But, and here's the magic, if a gravitational wave passes by, it actually stretches one arm and squeezes the other, just a tiny, tiny bit. That minuscule change is enough to knock the laser beams out of sync, and boom, you get a signal.
And when I say the change is tiny, I mean it is almost impossibly small. The arms themselves are 4 kilometers long, but the change they measured from that black hole merger was just 1/10,000th the width of a single proton. That is a level of precision that is it's breathtaking.
So how could they be so sure this signal was real and not just some random bit of noise? Well, the signal strength was measured at over 5.1 sigma. In science, hitting 5 sigma is like hitting the jackpot. It's the gold standard for a discovery. It means the odds of it being a random fluke are astronomically low. To put that in perspective, the scientists calculated that you would expect a false alarm this strong to happen from random noise just once every 203,000 years. So yeah, this was the real deal.
So what makes this one discovery so truly monumental? It wasn't just about finding one new thing in space. It was about humanity gaining an entirely new sense to perceive the universe.
I mean, this single event was a complete cascade of scientific firsts. It was the first direct detection of gravitational waves, the first time we'd ever seen 2 black holes merge. It proved that black holes this massive could even exist, and it confirmed Einstein's theories under the most extreme conditions you can imagine. This discovery literally opened a brand new window to the cosmos. It was the birth of gravitational wave astronomy.
And, the scientists themselves, in their official paper, put it with this beautiful historic simplicity. They just wrote, "This is the first direct detection of gravitational waves and the first observation of a binary black hole merger. Full stop."
And that just leaves us with this incredible thought, doesn't it? For centuries, for all of history, we could only watch the universe. Now we can actually listen to the symphony of space-time itself. The question is no longer if we'll hear anything, but what in the universe are we going to hear next?